the design pattern. So these are kind of a little bit different. So uh, similar but different. I think the responsibility pattern, where to assign the responsibility. We have different classes, we have different methods. It will tell you where to assign the responsibilities. We have like 8 responsibility pattern. So this is different. Grasp, GRASP, and we're in the design phase. We are in the design phase. We're trying to, so we're talking about designing our software. So um, this is not equal, okay? It's two different things. So the design pattern is basically, uh, you know, learn about the design pattern when I took a course when I was doing my master's. It's a software design methodology. There's a separate course for each phase. You can find the course for software requirements and specification. I did this course. You can have the course software design methodology. You can have the course for software testing. So you know, for each and every phase of software development, you may have a course. For example, in our department, if you go to the master, if you do masters, you have the software specification and design. I teach that course. So you see, for software, the specification, requirements, and design are involved in that class. All we're covering 2 phases there. So that's why. Um, so it's so this is very important, that you need to understand what you are doing, which phase you are in, and you know which tools you need to do that. Okay. Again, probably towards the end of this class, I'll review the whole thing again, like, so, because we got several complaints from the industry people that sometimes our students struggling with this design, because sometimes we try to find code it, you know, but coding is not enough. It's a software engineering is required. You need to understand the software development process. You need to understand each and every phase, which tools you need for each phase. Okay, how to use that things. You need to understand different responsibility patterns, how to develop the use cases, how to develop the sequence diagram, how to develop the communication diagram, how to develop the class diagram, now how to assign the responsibilities. Okay, and do you need many methods to convert one responsibility or one method? So all these things, you know, are important, and it depends on the experience that you have. Like if you have 2 years, 3 years, 4 years experience, so you can move from software you know, implementation to typical software development to design. So design people, that's why they get more money, you know, they get higher salary. So to understand better design, you need to understand all these things, the class diagram, sequence diagram, okay, and also different models you need to understand. It's not only about you know, the agile development process, because you know, but the companies, they're still using a waterfall model, then they're fine with that. I know that there's a kind of you know, there's a company there, Apex Analytics, so they're still doing you know, the waterfall model for one of their projects or something like that. So Cisco, they're using Agile. So Microsoft, they have their own software development model. Uh, Google, Apple. So Apple, I'm not too sure what they're using. Definitely, probably Apple or other things. But Google, yeah, they're using probably more. They're more agile, you know. So that's why you need to understand what models you need to use, what kind of tools you need to use, when to assign the responsibility, how to capture the requirements, how to capture the design, all this kind of thing. Okay, uh, I'm trying to give the similar things to you, because you probably you may not remember all the small stuff, but the main thing is that 5 phases of software development, the models, and the basic diagram, the use cases, data flow diagram, ER diagram, decision tree, tables. Um, if you say that, Dr. Roy, why we need the decision tree? just consider about an expert system, medical system. You need the decision tree, right? So flight reservation system, or maybe even I know that is um, what is the airlines, I forgot that one, they're still using the decision tree, so and the design phase, you need what, you need the sequence diagram or the communication diagram and the class diagram. And for implementation, you need to understand the refactoring. Okay, so sorry, I'm just again and again telling you, because I feel that you need to know all these things, small things. You need to understand the basic things. Then you'll find like, okay, I can use these techniques or these techniques, because nowadays all these things are available. Even your exam is now online. So, but if you don't know all the phases, all the tools, you don't know where to apply these things. So that's why you need these things. Okay, need this concept. Um, so as I said, that we just quickly try to cover the design pattern. So we have been talking about the responsibility pattern. We covered 8 patterns. So a responsibility pattern, to assign the responsibility to different objects. What is design pattern? Design patterns. The first thing is, do you need it? Yes, we need it, because if you want to work as a software engineer, software developer, you need to understand the design pattern. I'm going to cover only one design pattern, because it's kind of advanced topic. But as I know from this, from the industry, they want to know, they want to interview our students, and they want to see this concept, that you understand design pattern. Okay, and this is the most popular design pattern, so that's why I included that. So here, so there's a lot of design patterns are available. There's one book called Gang of Four, GOF. So they included 108 design patterns there. So we're going to cover only one here, because it's a little bit advanced topic. Uh, but it's why I need that again. The patterns help you build on collective experience of skilled software engineers. What does it mean? It means that, for example, you are in a situation, you're trying to solve something. You're trying to develop a particular software, and you are in a situation that typical software engineering principles or programming principles are not helping you. For example, you say, you found that, okay, you're trying to use inheritance, but it's not solving your problem. Is because we know that our main issue is that, can we our classes or objects should be reusable, so or adding reduce the coupling, how to improve the cohesion and all those kind of thing. To do that, so for example, if you're in a situation, you're trying to add the inheritance, it's not working. You're trying to do interface, it's not working. So then you can see, can we combine? If we combine these two approaches, does it work? If it works, then probably you can use it, and you can ask your colleagues or fellow members that, okay, it's working in this situation. So if you're sharing your code and with your colleagues, and they probably use it in the similar situation, similar, I mean, not exactly the same situation, but if it's a recurring problem in the similar situation, they can use that one. He can share these things with another colleague, so he or she can use that one. So you see, so that's why it's called a collective experience of skilled software engineers. So that's why it's very important, if you work together, if all of you can work together, the 3 people can work together, if 3 brains work together, that's why the term pair programming is very important. Like when 2 people work on the same machine, so for example, you're developing an algorithm, and 2 brains are working on the same algorithm, so it's called pair programming, right? And you're coding on the same, 2 people are coding on the same machine. So yeah, it's expensive, but it's a very, very good approach. When you're developing a complex software, this is a very good approach. So that's why when 2 or 3 people work together as a group, you can come up with a design pattern. Okay, and that pattern can be used in a similar situation. uh, uh, you know so that's why it's called the well-proven experience in software development, and it's probably basically help to promote good design practice. So you can go ahead without design pattern. That's not a problem. But when you start working and work for a company, you'll see that you need to understand the patterns, uh, design pattern, different design patterns. Different design patterns like the Java design patterns available, .NET and everything available. Okay. um, oh yeah, those are the links for those. And but again, if you just Google design patterns, you'll find a lot of design patterns available. So what are the elements of the design patterns? A design pattern may have the name of the pattern, why are you going to use that things, the motivation, intent and motivation, where to apply, what is the basic structure, the consequences, how is going to affect different your overall architecture, implementation, how to implement that things, and then the known uses. If you know that, okay, this is a typical situation where you can use that. So you can also have this information and the related patterns, all this pattern related to this one. So in a design pattern, you can find all these components. So what is this? And the design pattern is a collection of experience, experience of skilled software engineers. That's the important term. So you see, this is the important term. The collective experience of skilled software engineers. So when you have a solution, you can use the solution. Well-proven is the well-proven solutions, or experience and well-proven solution. You can use it in recurring problem, okay, or even for implementation of a software system. Okay. Okay, this is the basic method. So let's see a very simple example to talk about the design pattern. Okay, why you need the design pattern. Probably you're wondering about that. Like, okay, so we have, for example, we have a very simple problem. We have a company, like there's a company, they're trying to sell a duck pond simulation. Okay, it's called SimuDuck. Okay, and it has different kind of ducks, maybe the mallard duck, red-head duck, and you can include different ducks. And it has different behavior. It can swim, it can quack. Okay, so it has a different behavior, you see. Okay, so it has a display a method, is an abstract method, and each subclass has its own behavior, its own display behavior. Okay. So you see from the inheritance, you see that it's a mallard duck, red-head duck, and other ducks can inherit all these things. Okay, it's a very simple solution. So we started with the inheritance. Okay, so now you're trying to be very competitive. You see other simulation, and we found that their flies, their duck is also can fly. So you can use a fly method there. So now all the subclasses is going to inherit the fly method, right? If it's required or not, if it's going to fly or not, is going to inherit that. So solution. So what happened? For example, you're trying to give the solution, and someone is trying to add the rubber duck, and it started flying. Okay, flying around the screen. So you don't want that. Okay, what is the solution? You can override it. That's okay. You can override it. But how about the decoy duck? It doesn't fly at all. You don't need, you don't want to inherit this method at all. So what is the solution then? So that's why I see inheritance. You started the inheritance. Inheritance is solving your problem to some extent, but it's not giving you the flexibility, enough flexibility. Okay. Okay, so then you thinking of you can think of adding the maybe interface. So what you can do, you can see that, okay, you may have two interface, like flyable interface and quackable interface. Okay, and all the subclasses that needs this behavior, they can inherit that or implement that. Okay, so you see there is a duck class here. It is a basic behavior. Every duck swim. So duck swim and is an abstract method display, and all these subclasses, duck subclasses, has its behavior, the display. And so if any duck classes wants to add this fly method, implement the fly method, you can add it. You can add these things. Okay, that's fine. Okay, there's a solution. It's not a bad solution. It's still, you have this some kind of flexibility. But what is the problem here? Do you see any problem? Is it still pretty general, or can you reuse it? That's the thing. So you see, for example, you have 100 classes, subclasses that have implemented this fly method, and you, all of a sudden you try to change the fly method, to change it somewhere. Okay, so you think that no, you need to change the fly method. So what you need to do, you need to change in all the subclasses. That's the problem. There's don't have the flexibility, flexible enough. Okay, so you cannot reuse it. So that's the problem. So you need to change it, change the fly method. Okay, so the code duplication is the problem. So you're duplicating all this code like the for the fly and method. So what we found, we started with the inheritance. It didn't help. Interface, we thought that interface may help. The interface is not helping at all. So now you can think of adding a design pattern. So because typical programming skills like the inheritance, interface, they are not solving your problems. They're solving your problems to some extent, but those are not general enough to generalize the thing. Uh, for example, even it is true for AI model. It's a different topic, but for the AI model, what you need to do, make your system more, um, um, generalizable, so that you can see one solution. For example, it learns from one thing, and it can detect the thing. For example, if your system is trained, right, the AI model, what is that, you have your system is trained based on a typical few samples and similar samples, but and then your system may not generalize. You just if you have a different kind of sample, it may not recognize it. But if you have a smaller sample size, it's not big, you don't need a big amount of data, but if it's a smaller sample size, but you have a diverse samples, okay, so it can detect new samples. The similar kind of thing, the facial recognition. For example, your system is built on a uh, um, on people of USA. Okay, so it sometimes is really hard to recognize the faces, like the Asian faces. Okay, and all those kind of things. So that's why if you have a system that can, if you have different diverse samples, so that's why diversity is important. So you have diverse samples, and you can train the system, it can generalize better, and it can detect it. So similarly, in a software engineering, to make sure that your solution is more general, reusable. This is the basic. It's a very important thing. You need to understand it. That your class can be used not only for this purpose. Maybe it can be used in another situation as well. But there might be some situation where you have to be you have to develop something that is very specific to this situation. That is fine. But the main idea is to make your system, your classes more kind of reusable, more general. Okay. Uh, okay. So as I said, that we're talking about the design patterns. It is the collective experience of skilled software engineers. You as a software developer can develop a design pattern. That's not a problem. Even when you're doing your projects, you can come up with a design pattern. If three of you are working in a group, and you're trying to solve something and came up with a solution, and if you see that your fellow members can use it in a similar situation, that might be design pattern too. So the design pattern, you see that when the typical programming principles or design principles don't help, then probably you can use a design pattern. For example, in this case, we started with a typical dark class, dark and several subclasses. we started the inheritance. So all the subclasses inherit the behavior from the superclass, dark superclass, like quark, swim, and display has its each subclass has its own behavior, but they're inheriting everything from dark superclass. But for example, if you want to add one method, it will inherits all the methods. It inherits these methods to all subclasses, but some ducks may not fly, but still inheriting these things. So then you try to use the interface, the flyable and workable interface. Then you found that okay, if it's different, you can add a different one, even subclasses. But if you want to use the fly methods in different subclasses, you can still, if you and even to change your fly method, you need to change in every classes. That's the problem. So that's why it's not um, it's not flexible enough. Okay. So that's why you saw that inheritance is not working, interface is not working, and in that case you need to think about a design patterns. So the design patterns, okay, design for change. Okay, so what is the concept? Try to see your system, your application. Try to identify the aspects of the application where likely to vary, where likely to change, and try to separate them from those which remain the same. So you see your applications and try to see which part of your systems are changing or vulnerable to change. Take that part out, encapsulate it. Okay, so this is important. So if you see your system, see your system and try to see which part are changing a lot. So you see like the swimming behavior, display behavior, what is that? So if you see the behavior that are changing a lot, take that thing away from the main implementation. Okay, so so if you see that, so here if you see that, which part of your system are changing, can anyone tell me? Anyone can try? So here um, you can see the fly and quark behavior, they are changing a lot. Okay, so in that case probably what you can do, so that is our plan, that identify the aspects of the application, identify the behavior that are changing a lot or are vulnerable to changes. So that so you can take that part away so that you can extend it, modify it later without disturbing the main implementation. Okay, so you found that okay, your this part is swing display is not changing in at all, but this part is changing. So take this part away from the main from the main implementation, and maybe replaced by the flyable and quarkable interface. Let's see, for example here. um, um, so we call it design to an interface, not to an implementation, right? So so here you can abstract this as a fly and quark behavior changing. You can take those part away and replace you can create a class hierarchy for these two behaviors. Okay, why using the hierarchy? Because you may have different fly behavior, different quark behavior, so you need a hierarchies. So you take this part away from the main implementation and replaced by a class hierarchy. So it's a different fly behavior, different quark behavior, and something like that. So here you can see, so that's why the goal is to design is designed to an interface, not to an implementation. Uh, so so you're moving the specific behavior types, fly and quark behavior, away from the immediate dark hierarchy. So we are taking the implementation of the behavior out of the class and replacing it by the interface. Okay, so that's the thing. So you are taking, so this is the solution. Okay, so we found that these two things is changing a lot. We take them away from the main implementation data, and it is replaced by its own different fly behavior, and with the class hierarchy is a different fly behavior and quark behavior. What is the advantage of this? So for example, you want to add another class here. So you can easily add it. You have to go through this and implement this, right? And place one of the fly behavior or quack behavior, or any different kind of fly behavior like fly with wings or fly no way, quack, squeak, mute quack, what different kind of quack behavior. So you see, you have to go through the dark classes and you can implement different kind of fly behavior or quack behavior. So now, for example, you need to add, you see how the solution is pretty general and reusable. Now you can add another fly behavior if you need. If you can add another quack behavior if you need, you can take out one fly behavior, that's fine. It will not affect the main implementation. Here you can add another duck classes, subclasses, duck subclasses. It will not affect the these things or this part. Now, for example, you need to use the fly behavior for bird class. You can also use that one if you need it. So the solution is more general, flexible, reusable. So that's why this is the kind of a solution. Again, you can improve it, but this is a kind of flexible solution, more usable solution. So this is a design pattern. We used a design pattern. This is our first design pattern we used. So if you use the and also what you can do, for example, you're trying to use your duck is flying, and duck is changing the behavior on the fly. For example, it was flying, is flying with no wings, then it's changed to fly no way, something like that. It started flying and is flying and then started walking. So you can change the behavior during runtime as well. So you can make the system very flexible. So now you may have add many fly behavior, quack behavior. Even you can use the fly behavior, quack behavior for other classes apart from dark. For the dark classes, you can add many subclasses. It will not affect anything on the left. So you can inherit or implement everything. If you need to go through the dark classes, and you can implement any kind of fly behavior or quack behavior. So it's a very flexible design, but at the same time you can make it more flexible. For example, during the runtime, some is from you can change the behavior from flying to speak, from fly behavior to speak behavior, something like that. So so here you see this typical code, the abstract the class dark classes. You have this quack behavior, fly behavior, um, and you have trying to perform quack and perform fly, and you're extending it. So it's the mallard duck. So you're implementing quack behavior and fly behavior. Okay, so and the implementation of the fly behavior, the interface of the fly behavior is like this. You can similarly do it for quack behavior. So fly with wings, you can have the fly, I'm flying. So fly no ways, I can fly. So here you can, so there's the generalizing. So if you want to generalize the things, so for example, it's you just change from quack to speak, something like the quack to squeak or something like this, um, so here this is the thing, how to generalize it. Wouldn't be nice if you could allow individual ducks to change their behavior on the fly, so to speak, something like this. So so to do this, we can add two additional methods like the set fly behavior, set quack behavior, and so this is, you're getting this quack behavior and fly behavior. So now you need to implement it. So you have the model duck, for example, as an extend the duck classes. So so here the quack behavior, the fly behavior, so is trying to quack and fly. Okay, so now you just try to implement and run it, the model duck, trying to fly. So I can fly because fly no way can fly. So now I'm trying to implement set fly behavior. So it's changing the, adding the some dynamic behavior. So now set fly behavior new. So it was not flying. So now you can adding fly rocket power. You see, we added two things is two behavior here, set fly behavior, quark behavior. So here's a new fly rocket power. So then your model that perform fly, you see flying, I'm flying with a rocket. So now it's implementing this one. It's not flying, now it's flying with a rocket. So it changed the behavior, okay, during the runtime. Um, so so here what you did actually, you take that. So this is the final solutions. You see, you have the dark classes, you have all this behavior, the methods here. So you try to find which part of our system are changing, the fly behavior or quark behavior is changing. You took them away from the main implementation and replaced with this their own class hierarchy. So you have different fly behavior, quark behavior. Even you can change the behavior during the runtime. You added two additional methods. So here you can add more subclasses. Here you can more subclasses, different adding fly behavior, quark behavior. So you can encapsulate the flying algorithm. Here you can encapsulate the quark algorithm. So we try to encapsulate that part which are changing. Since the fly behavior is changing, quark behavior is changing, you encapsulate that. So so it's and you can take them away from this main implementation part. So this is the one solution. So now this is our this is a very you know it's a very naive example we have seen. Very we try to make sure you understand it. um, Try to tell the story why we need the design pattern. But you have some real situation. You see, this is the situation. For example, during this Christmas time, you're trying to get some your shop, or you're trying to develop a software, and you're giving some kind of discount. For example, there's a different behavior. For example, it's a uh, and for example, you try to compute sales discount like 10% discount, 10% off, 20% off, 10% off if the total tax is more than $100, something like this. So you have different strategies. So how to implement that different kind of strategies. Is a very simple situation like 10%, 20%, 10%. So you can add more. You may add more situations, or you may take some part out. So how can you do that? How your system or class can try to consider all these kind of varying situations? So in that case, probably you need a design pattern that we develop. uh, so you started with the inheritance and ended up using the composition. You started with the easier relationship, like mallard duck is a kind of a duck, red hat duck is a duck kind of. So now you have a composition has. So this duck has these properties, fly behavior has these properties, something like this. So start with the easy relation, and now we have the composition. Okay, so what is the name of the first pattern? Is called strategy design pattern. Okay, so keep that in mind. So you have only one design pattern, and you will get a question from here. So you need to know what is the design pattern. It's a strategy design pattern. We solve only one design pattern. It's an advanced topic, but you need to know, you need to understand. Strategy design pattern is very uh, it's a very popular pattern. Another very popular pattern is a singleton. You can go ahead and check it. So strategy design patterns defines a family of algorithms and can encapsulates each one and makes them interchangeable. So this is the strategy lets the algorithm vary independently from clients that use it. So this is the important thing, the strategy design pattern. Okay, the first this is called gang of four pattern, GOF, the strategy design pattern. So this is the story of how you should use the strategy design pattern. Okay, so any questions regarding the design pattern? Okay, if not, then let's go to the brainstorming session. Here, I have this problem. Okay, now you need to solve it. You have until maybe 2:30, 4:30. Sorry. So here, so this is, you can use the similar thing. So you see, the refactoring involves rewriting or restructuring the code, modifying the code, improving the code without changing its external behavior. It's basically you just try to clean up the code. Okay, there's a simple way to talk about the refactoring. So what is refactoring? You're trying to improve the code. Okay, there's a different way you can improve the code. There's a different techniques for refactoring. We're going to discuss that. So what is that? You need to refactor the code to improve the quality. Okay, for example, you have a very long method. It's doing a lot of things, or you have a class is doing a lot of things. So what you can do, you can change, you can divide. It's a long method to some shorter methods or something like that, to make it highly cohesive, to make it a little bit to reduce the coupling and something like that. So it's basically the refactoring is trying to improve the code, clean up the code, restructure the code, reorganize the code without changing the external behavior. But one important thing about the refactoring is that once you refactor, you need to test that portion too. Using the test driven development or unit testing. You're already doing unit testing as a part of the project. So, and since you are doing the you're deploying or using the agile development model, right? As you develop the agile development model, the sprint one, you're going through several sprints, 1, 2, 3, and 4. So what you need to do is that for interaction diagram. So okay. So what you need to do, you need to add basically what you need to add, you need to make sure once you refactor, it means that you already restructure or reorganize the code. For example, you have a long method, you convert that long method into several short methods. Okay, so now to make sure whether your codes are broken or not, you need to do the testing. Okay, so that's why the refactoring and test driven development, these are the two very important tools for agile development process. It is agile development process, as I mentioned, is a kind of philosophy. You can change the requirements, you can add the requirements, you can get the feedback, early feedback from your from the user, the stakeholders, and you can get back and try to change the change the code. That's fine, but and you have to go through several sprints. That you already know, but always try to make sure the refactoring is very important. And also another important thing is test driven development. We'll discuss it in the testing phase. So so refactoring, once you refactor, so to make sure that your codes are not broken, what you need to do, you need to quickly check the you need to quickly test the code. You need using the test driven development. Okay, so test driven development is not practical unless you test each and every modules you just created from the previous module or something like that. So that's why in the agile development process, the refactoring and test driven development, those are two key concepts. Okay, always remember that. The idea is that in the refactoring, refactoring can be done in small steps. Okay, it's a very small step, and then you can do the testing. But even if the small changes, but many small changes can add up to a major improvement. Okay, so you just, for example, you see the name of the variable is really hard to understand the purpose of the variable. So try to make sure you try to rename it. It's a very small change, but it will really helpful. Sometimes you see the subclass, superclass. Okay, so or maybe you have a several class, they share a common feature. So how about you can make a superclass subclass relationship? Okay, so this kind of thing. So you can see a long method, very long method is doing a lot of things. you can change and convert the long methods into several short methods. So you see, it's a different ways you can refactor the code. But once you refactor, so there is small steps, but if you can add them, so it can drastically change or improve the quality of your code. That's why the refactoring is important. And it is not about only the tools and techniques you need to apply. It depends on your skill as a software developer, or experience as a software developer. It's not about skill, it's about your experience. Okay. So that's the thing. When you start implementing the thing, refactoring is an important part. So you can refactor the code, improve the code, clean up the code using different refactoring techniques. But once you refactor a module, you need to test it. Okay, using test-driven development. So I already mentioned about yeah. So already mentioned this before. What are the things you can do? Goals in the refactoring might be, it's like removing the duplication. You can see that some duplication in the class. You can remove the redundancy. You can try to improve the clarity to make it clear. Okay, make longer methods shorter, as discussed. Remove the use of hard-coded literals, etc. So idea is that you need to make the code short, tight, and clear without duplication. Okay, so another important concept, code smell. You know, when you for example, you're trying to they always use, the software engineer use the metaphor like if there's something in your refrigerator smells bad, so it seems that there is something. You need to look around and identify what it is, why it's bad, where you're getting this bad smell or something like that from refrigerator. So you need to see that. So it's pretty much like that. When you see this code smell, it smells bad, your code smells bad, it's basically you need to make sure, probably you need to refactor the code. So when you feel that your code is smelling bad, it's when you see the duplication, when you see there is no clarity. So when you see the variable names, you don't understand it. When you see a module of the code, you don't understand it. So it seems like that there's something wrong. You need to improve it. So that's why the software engineers is basically that use the term code smells. Okay. So test-driven development, I'm going to discuss it, but what is test-driven development? Because as I said, that once you refactor, you need to test each and every module using unit testing. So test-driven development is an important concept of agile development process. So what you need to do, you need to start with the for the test-driven development, you start with the test code. Okay, I mean the class to be tested. Okay, create the code for that. And then you can create a simple production code. Okay, so and then compare. So start with the test code and the production code and then compare. So it's basically what you need to do, you try create a kind of a try to see like some kind of test code before the class to be tested. Pick the class that you want to test, create the instance of it, try to find the operation that you want to test using different values, and evaluate the results between the expected values and the real values. Okay, so you create the test code, or maybe a simple test class, that's fine, and then create the production code. So you're creating the test code before the production code. Okay, so test code, the production code, and then try to find which class you want to test, then which method you want to test, create the instance of it, and then perform some operation that you want, for example addition. So try to pass different values and try to get the results, like, and try to compare what is the expected results and the real one. Okay, so there's a different refactoring pattern. You can consider it as a pattern. So there's a different way you can refactor. First is extract method. it's a very popular method, and probably you can get one question from here. The extract method is basically you can convert a long method into a shorter one by factoring out a portion into a separate helper method. Okay. Extract constant. So it's basically replace a literal constant by a named constant. This is important. Introduce explainable variables. So try to use a variable name that can explain the purpose, its purpose. Okay, so that's why it's very simple, but you can do that. Still can add a lot. The collapse hierarchy. You can see, for example, you have 2 or 3 classes and they share a common features. So you can make a superclass subclass relationship that you can do. Okay. So the common features may belong under superclass. Okay, because the superclass and subclass so inherits a lot of things. The superclass, for example, here employee. Employee and department is a part of party. Okay, so before it has like department and employee, they have some common features. Okay, so for example, get name or something like that. So instead of having 2 classes, you may have superclass subclass relationship. So these 2 classes may have common attributes and common functionalities, and but the subclasses may have some additional attribute as well, or additional functionalities as well. Okay, so they inherit everything from here, the party class or something like that, but they have like employee and department, they have their own behavior or own own attributes. Then the replace assignment with the initialization. Okay, so for example, instead of doing this integer I and then I equals 7, instead of doing this, do the replace assignment with the initializations, straight with the initialization. Substitute algorithm, it's definitely when you see that your algorithm is bad, it's not working very well, it's not fast, it's taking a huge amount of time. For example, nowadays it's happening. For example, you have you develop something for CPU, but you definitely need it for GPU machines, right? So how you can run it in the GPU machines? So sometimes you need to change the part, or you need to rewrite the code so that you can extract the extract the characteristics from the GPU machines to make your code a little bit faster. Okay, so there are some typical examples of refactoring. So first, again, what is refactoring? When you in the implementation phase, you start refactoring, you need to refactor to improve the code or to clean up the code. So once you refactor, you need to test it as well, because you're not too sure whether your codes are broken or not. So you need to test it using test-driven development. Okay, so what are the refactoring things? What you need to careful about? One thing is a code smell. It's basically when there's a duplication of code, there's a long method. These are some symptoms that there's something wrong. So what you can do, you can try to use the refactoring. So there's different refactoring techniques. For example, extract method, it's the most popular one. So we have a long method, you can make it into shorter method. Extract the constant, replace the literal constant by named constant. For example, you can use the explainable variable, the variable that can explain its purpose. Hierarchy, that's also it's also used. For example, merge a superclass and subclass together, that you can do. And also replace the assignment with initialization, and definitely is another thing. If is a drastic change, it will be if you want to substitute or rewrite the algorithm, because if you see that current algorithm is not fast enough, so you need to make it faster. So definitely you can use different algorithm or to make it work. You can do that. So all are part of it. So some refactoring techniques are discussed in this. If you go to the click this link and you'll find it. Okay. Some code smell, as I mentioned before. Okay, so when you see the smell, you see this duplicated code, right? You see the big function. So classes with many instance variables, classes with lots of code, similar subclasses. You can see there's no use of interfaces. That's another thing. You can extract the interface. High coupling. High coupling between objects. So when you have the high coupling, is you see that it's possibly one classes have many methods and they're all connected. So one class is connected to the many other classes. So these are some common code smells examples. So this is definitely not the exhaustive list, but you can get an idea about what you mean by code smells. You see that's so when you see those, you'll definitely try to restructure or refactor your code, okay, without changing the external behavior. Okay, so here so refactoring. So here is a simple another one example here. You can see. Now we'll see several examples for refactoring and class diagrams. Okay. So you see this example. So this is a class player void take turn method here. It is taking the turn, is doing two things: taking the turn as well as rolling the dice, right? So it's basically it's somehow affected with high coupling maybe or low cohesion. So how you can do, you can use the extract method. Okay, so instead of having one long method take turn, you can convert it to two small methods. For example, shorter methods. So for example here, take turn, okay, and it's rolling the dice, and you just call it here. You can use it here. So it is just taking the turn and it's rolling the dice. So it has two things. So now it is these two methods become reusable. So you can use this one for another purpose. Okay, but if you use both, and if you want to use this, for example, you want to use this method somewhere, but it is doing two things, but you need only one. So you see, it's probably, if you are to you have to use only roll the dice, but it's may affect the entire class. So rather than now, if someone another class is using this one, they'll be connected to this one. You need to worry too much about this method or something. Okay, so in this way you can. So now this class, the class player becomes highly cohesive. Okay, before it was not that cohesive, it becomes highly cohesive. Okay, you can it depends on the ID you're using. You can use automatic refactoring. I always use NetBeans, or if you want to use Eclipse, so you can go there and use the right click, select the code that you want to refactor, and then try to right click, create the method name. It will do the refactoring automatically most of the time. Okay, so it depends on the ID you're using, but Eclipse, NetBeans, they offer it, they support it. Okay, and most of the IDs they support this the automatic refactoring. Okay, so refactoring is a very important thing when you do this agile, when you following the agile development process. So agile development process, as I mentioned before, so this is the refactored code. It's done automatically. So the agile development process, as I said, that is changing. You can change the requirements, and you can come back and add more requirements. You change the use cases, add something, modify it. You can add modify your design. So and you to go through several sprints, that's fine. But one few important things about the agile development process: the refactoring is important. Test-driven development is very important too. Okay, so the use cases, user stories, sequence diagram, the interaction diagram, the class diagram, and you map the class diagram to code. And then once you start coding, you need to refactor. And then once you refactor, you need to make sure that the codes are not broken. What you need to do, you need to do the testing using test-driven development. Any questions related to refactoring or anything? Okay, so there's another example here. Refactoring is always, it's not necessary that you have to refactor. Sometimes you can make the thing worse, you know. So for example, here is the top part you see. Is talking is in so Boolean is leap year. Okay, integer year, year is like, this is the simple logic is here. And then now you're trying to introduce the explaining variable concept. Okay, so Boolean is leap year the same, but here Boolean is fourth year and all this kind of thing. So uh, so is it really necessary or not? It's probably not necessary. So also another thing, um, you can use that, that's fine, because it's once you have this explaining you have this explainable variable concept, so it looks pretty good, because here it's really, you need to go deep and understand it, but now you're using the name of the variable, explain its purpose, so it's pretty clear now. Okay, but here for example, you have this one, but can you do this one? For example, instead of using the explaining variable, you can use some the comment section. You just put everything in the comments. Is it really better than this one? So that's the thing, probably not. So so it's not necessary that you have to the refactoring all the time, but just make sure that when you refactor, it should improve the quality of your code. This is very important, otherwise it doesn't make any sense. Okay, and once you do the refactoring, you definitely try to try to test that module. Okay. Okay, so any questions regarding refactoring? So here we have another for example, the method we have using print account details. You're doing print summary, printing history. So can you refactor this code? What do you think? How to refactor this code? So here, because here we can see is doing, so is printing the summary, you're printing the history, right? So how about this? You just make it like 3 shorter methods. It's only doing the account details and do this print the summary and history, and you have 2 different methods for doing summary, printing summary and the history. So now you see this is it becomes more it's a highly cohesive. Okay, we can understand the purpose of each method. Okay, so it's called extract method pattern. Okay, so it's basically what we have for. Okay, let me share my screen. Okay. So can you see my screen?
Yeah.
Okay, thank you. Okay, so as I said, that today is basically we are going to talk. We are done with what do you call it, the requirements and specification and the design and coding. So today's we are going to talk about the testing phase. Mike already discussed about this testing, unit testing basically. So you are doing testing, even for this sprint too, you're going to do the unit testing. So
we'll talk about the testing. This the fourth phase of software development. Okay, so we are done with the requirement, specification, design, and implementation. Now this the fourth phase is testing, verification, and validation. And the next phase is the last one is the maintenance and the quality management. Okay, so okay, so the testing is basically what is testing. As you already know, you have been doing testing. Even it's a part of your project that is assigned by Cisco. So it's basically it's testing to see whether your code is running well or not. Is there any bug or not? Like, are you getting the expected output or not? What is your what is the input and what is your expected output? So whether each modules are working pretty well or not. I mean, each modules means each classes or the particular method of that class, and then how about if you can put them together, and how they work, you know, or maybe how the whole system is working. So this is basically it's basically testing. So there's two kind of testing. You see the verification and validation. The validation is basically do you have did you build the right product? That's the important thing. Do you have the right product? So it means that so you have the specification, right, or the requirements. Did you capture the requirements well? uh, did you know, did your specification actually solve the problem or not? Like, wow. So, and whether your specification matches the problem that you want to solve or not. That's one thing. So, and then the design is basically whether your design matches the specification, you know. And also another important thing is, okay, so once if it's the design matches your specification, then whether your coding, the coding part or codes match the design or not. So this kind of thing. So it's so if you have a good specification or requirements that solve the problem or that capture the requirements or all the specification, then if your design matches the specification, and then if your implementation matches the design, it means that you have the right product. Then the verification is basically, did you build the product right? uh, I mean, like whether your software is running correctly or not. um, uh, what is your expected you know, output, um, based on your input. So this is basically the testing. So the first is validation, as I said, that whether you build the right product. So it means that whether your requirements capture requirements document capture all the requirements that your clients want, and or the specification capture all the specification, or actually solve the problem or not. That's one thing. And the next phase is definitely how your design is matching your specification or requirements, or whether your implementation is matching the design. So if you have a good match between this implementation and design, and design definitely captures all the requirements and everything, it means that you have the right product. So another thing is that the verification is did you build the product right? So whether your program is or the software is running correctly or not. So this is basically two kind of testing, is the validation and verification. So how can we test? How do we test? There's basically different ways we can test. The unit testing is a very important part. Even there's a very important for test driven development. That's why we assign the projects to you. The unit testing is the basic building block. So you try to test each and every part of your system or programs. Like we try to test the classes and the particular methods or all methods of that classes. And then this is basically the unit testing, you know. And then if you put together a few classes, a few modules and classes, and try to see whether they work or not, you know, how the modules and classes work together is basically the integration testing. So here you can see that uh, you can see this is the unit testing is basically how the each individual methods or classes, you know, are working fine or not. It means that what is the input variables and input values, and what is the expected output or the real outputs, and can you compare them? This is basically the unit testing. uh, and then if you put together maybe unit testing module 1 and 2 and try to see whether they work together or not, is basically the integration testing. The validation is basically, as you see, whether your requirements have been made or not. That's the validation testing. I mean, your specification document solve the problem or not. The system testing is basically you put everything together. You all the when you test each and every classes or the modules, put them together and then test the entire system as a whole. Is basically the system testing. So it's basically and there's this 4 kind of testings. You see the unit testing, basically. Uh, Try to test the components, the smaller component first, and then broaden the scope. This is the general principle. So start with the unit testing, try to see your classes are working or not. Try to pick a method if you have several methods, and try to pick all the methods or few methods and see whether your class is working well or not. And then integration testing puts few more modules together and try to see whether they work together or not. And validation testing is the whether requirements have been made or not. System testing, as we know, that's you put everything together and try to test the entire system as a whole. Okay, so this is basically the different kind of testing. So in this class, we will mainly focus on the unit testing because we are focusing on test-driven development, and this is very important and for agile development process. I mean, like, test driven development is part of agile development process. So okay, the goal is demonstrate. What is the goal of unit testing? Demonstrate that individual components perform correctly. So that's important. So what you should consider, you should consider, for example, data entry and exit. Okay, what is the for example, the function parameters, what is the return values. You can try different input combinations. Okay, and we will see a demo definitely. We get different combination and try to see the expected output or real output. Was there any difference between expected output or real output, something like that. The local data structures, try to see whether there's values don't change unexpectedly. Okay, the code paths, and see is there any issue in your for example, in your if then statement, switch statement, or loop, or or for the flow control, any issues in the flow control. Okay. The boundary conditions, the loop endings, that's very, so definitely the loop, and try to see the overflow, try to see the range, so this is the boundary condition. The special cases, and definitely if you see, for example, try to find whether is there any empty data structures or not, is there any unexpected input, and and etc. So those are basically you need to consider all these cases when you do the unit testing. Okay. So here, as I say, the module interfaces, first thing is definitely try to see the entry and exit condition for a particular function or a method. So this is very important. Try to see, and this is a very common method for testing, for unit testing. If these are not being made, it means that something bad may happen. Okay, so so what you need to do, try to see whether parameters, you pass the parameters to the functions, and those the parameters are valid or not. Try to see the return value and see whether it is expected return value or not, or try to make sure there's a known local data structures or modified. Okay, unless you have something in your documentation that okay, you can expect this kind of modification in your data structures. So this kind of thing. So as a module interface, I just always try to see the entry and exit conditions. Again, so few things you need to consider. For example, the parameter passed to a function are valid, or what is the return value, and the return value is close to the expected value, or equal to the expected value or not, or is there any is it a change in local data structures. Okay, the code path is basically try to see your see the if statement, switch statement. Okay, try to find, like, is the logical flow, is correct or not. Every possible path should be tested independently. So if you see that, okay, one path is or some branches or one branches is working pretty well, it doesn't mean that other branch will work well too. uh, 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 so this is also that's the thing. So if you this is very important. So it's try to see the code path, try to see check the logical flow of the program, try to check different kind of as an if statement, switch statement, and all the loops, and try to see if there's an issue or not. Okay, so try to find, it's not about you will check just only one brand, uh, so here. So yeah, so this is basically window. Okay, so I'm getting a message from, okay, let me, okay, so here so it's basically the code path is try to check the if, switch statement, and the loops, or try to check the not only one branch and several branches, and make sure that all branches work well. Okay, so the boundary conditions is always interesting to see what's happening on the edge, because for example, the range, try to anywhere in range occurs in your code, it's wise to test what happens before the each end of the range. So at each end and just after each end or something like that. So it's basically if it's like an n, is the range is n, and then what's happening at n minus 1 or at n plus 1 or something like that. So this also applies to loop limits. So for like array subscript or data storage overflow. So for example, what may happen if you need to have n plus 1 bits in an n bit data type. So this kind of thing. So the boundary conditions try to check the range. It's not only what's happening at each n, just before the n and after the n. So you need to check all these things. So the unit testing in object-oriented software. Uh, so we all when you do the object-oriented, so it's you need for example, we're developing an object-oriented software. So in that case, what you need to do, and definitely we're going to use the polymorphism. Maybe we are going to use the polymorphism. In that case, you may have a particular operation may vary at runtime. Okay, it may vary. Your operation may vary. For example, if you can see the interface here, the tax calculator, you have different tax calculators. And you can see that get tax polymorphic operations, and it is this operation is different than this one. Okay, what is used in this subcategory or subclass. So that's why. So just we have to make sure to careful that we have to test all the possible variations, because they change the behavior at the runtime. Okay. So you have to be a little bit careful when you do the unit testing in object-oriented software development process. The black box testing, that's another thing is you already know about that. So black box is we don't know what's happening inside the system. So we just to see we know the input and output and some control. So but we don't have much control on the on the processing side. So what you can do, so we can just quickly check what is the input values and what is the expected output values. Okay, so so it's basically, as I said, that just to verify the inputs and outputs of a component without analyzing the structure of the component itself. Okay, and then then we have this white box testing. Okay, so white box testing is basically what you need to do here. Um, this is just kind of opposite of black box testing. So the black box testing, you're not worried about what's happening inside the system. So rather you're just focusing on input and output. But the white box testing, you need to analyze or consider every internal details of the component being tested. So for example, um, just consider like is a typical four function calculator. So if you want to check the four function, very simple four function calculator, you need to do a exhaustive test, even for a simple four function calculator. So it's not that easy to do the white box testing. Okay, so but again, the black box testing is very popular for that reason. So if you, once you have the input and you have the expected output, and probably you have examples, your uh, I would say your components are running well. Okay. uh, Okay, so one of the focus of this class is test-driven development. As I said, that it's a very important part for agile development process. Even you're going to do that in the sprint 2 as well. So you need to create the unit test for sub function that you created in sprint 1. So similar kind of thing. The test-driven development is a very important part of agile development process. So what is the basic philosophy of this test-driven development? So it's basically you need to write the test code first, even before you write your production code or the main code, So it's pretty interesting. So the basic the steps are like this. So the first you start with a little bit of test code, okay, and then a little bit of production code. And then you test the new production code and refine it until you are satisfied, until it passes, repeat from step 1 again. So it's basically, I would say, you can start. I will check one example definitely. So what you can do, start with the very simple the skeleton code. uh, Definitely you cannot have you need some a class. You just, for example, you want to test a class. You just create the class, the skeleton class. You don't have anything, for example, it doesn't have any method or anything, or a simple method without having anything inside it. So and you create that one, and based on that you can create a unit test class, and then you can come back to your production code, and then you just add the method that you want to test. Um, and then go back and test again and come back to your production code. So you have to go through several steps until your class passes the test. Yeah. uh, so, and also there's a lot of automatic tools available. For example, if you want to use Eclipse, NetBeans, Apache NetBeans, so you're fine. So for example, I was trying to do the Apache NetBeans, but it's not very working very well because of the version probably. So I'm using here in the demo, I'm going to use this the simple NetBeans, but you can definitely use Apache NetBeans now. It's pretty interesting, and I can see it's worked pretty well for big data environment. Uh, okay, so again, so test-driven development, you need to understand. So as I mentioned before, that um, you need to understand few things, few concepts very well. That's one thing, is as I said, this 5 phases of software development. So for this software engineering, 5 phases, and then you need to understand the tools and techniques you're going to use for each phase. Okay, for example, again, I mentioned it several times. So for example, the use cases for the requirements, the specification, you can use the ER diagram, the decision table, decision trees, state transition matrix or diagram, DFD. You can use ERD and DFD even for the design phase as well. Okay, and depending on what problem you are going to solve. And then another thing is, for the design phase, as I mentioned, is even for requirements, you also may have the system sequence diagram. okay, where you can find the system operations. The design phase, you have, for example, operation contracts. It shows the behavior of the operations, and to show the behavior of the operation, you can draw the communication diagram. So communication diagram has two format, as I said. There is a interaction diagram format. Sorry, interaction diagram has two format. It's a communication diagram format and sequence diagram format. You can use any of this method. That's fine. And then based on that, and you can also develop the domain model to capture the concept and the attributes and its type. And then based on the domain model and the interaction diagram, you can develop the class diagram, which might be the final output from the design phase. And then the coding, you just design, you map the design from to code. You need to maintain the order of the implementation. And few things, when you do this, assign the responsibilities. You remember, when they assign the responsibilities, when you develop the interaction diagram, you need to understand a different responsibility pattern. We consider all 7 or 8 eight responsibility patterns, starting from the creator, information expert, to indirection and pure fabrication. So the creator, these are the responsibility pattern, not the design pattern. The responsibility pattern are, we call it grasp. The responsibility patterns are creator, information expert, controller. The controller is very important. A controller class for interaction diagram. And many people made mistakes in the even your makeup midterm. Your interaction diagram should always start from the controller class. Okay, and we discussed different controller class, the use case controller and the system controller. For example, you can use system controller, the controller that represents the class that represents the entire systems. For example, app, system, terminal, and all those kind of things. So again, so the controller, and then we have two other very common responsibility pattern, like coupling and cohesion. And then we also talked about the polymorphism, indirection, and the pure fabrication. So these are the 8 responsibility pattern we covered. They show actually where to assign the responsibilities. For example, we have several methods from SSD and different methods, and we have these interaction diagram, or we have the domain model. So where to assign those responsibilities, where to assign these methods. So your responsibility pattern of 8 responsibility patterns can help you with that. We also covered the one design pattern, is this collection of experience of skilled software engineers. So it's what you can do is we did this strategy design pattern. So now so here so we are talking now about the testing. The testing phase, we know there's the 2 kind of testing. You see, this overall is validation and verification, but different methods to do the testing is like unit testing, system testing, and integration testing. So so unit testing is very important. So especially the test-driven development. The test-driven development is basically part of our agile development process model. So what you do, you develop the test code, then the production code, and then test the new production code. Okay, and you can do this process until your code passes. This is basically the test-driven development. So there's different automatic tools are available. As I mentioned, the JUnit for Java, XUnit, CPP unit for C++, NUnit for .NET or something like that. So you can use a very, if you're using JUnit testing, so you can definitely use nice IDE like Eclipse, NetBeans, basically Apache NetBeans. You can do it automatically, so you can have some URLs here. So in a JUnit example, you can see. How can you use test-driven development, the philosophy of the test-driven development with the JUnit? Okay, so for example, you remember we have the cell class where we're talking about the point of cell system, that the system that we were developing. We're developing the software. While developing the software, we are trying to discuss each and every component, starting from the requirements to software maintenance. Okay, so here test-driven development is basically, for example, what you need to do. You need to test the cell class. So unit testing, test-driven development, we are doing this unit testing. So it's basically you pick a class and particular, and then um, mm, mm, uh, so create the instance of the class that you want to test, then pick a method that you want to test. Okay, and then you try to verify whether test work as expected or not, using as a true method is the essence of JUnit testing. So what you can do, the first phase is you pick the class. Okay, JUnit testing, what is the rule? First pick the class. Okay, I want to test this class. So then which method you want to test? So create the instance of the class, and then probably you need to verify using the assert JUnit assert true method. Okay, to see whether your test is working well or not. Okay, so here an example is given. So for example, it's you want trying to do the cell class, and you have a method. You want to test the method like make line item. Okay, so you have the cell class, and you have to develop the make line item to test the make line item method. Okay, so you just create the test class. Okay, and then you have create the fixture. Fixture is basically create the instance. So you're creating the instance of this of the cell class. Okay, uh, now execute the method to test. Which method? So you're going to execute or test the method make line item. So you're passing the values desk1, desk2. Okay, and then the last phase, step 3, is evaluate the results using the assert true statement. This is the essence of JUnit testing. So again, you start with this. You create the first step, create the fixture, create the instance of the class or object that you want to test. Then the next, you see cell, fixture, new cell. The next phase is definitely the method they want to test. Okay, and pass the parameter, different values. Okay, let me change that. Okay, okay. So what you need to do is um, okay, so again, first check this, create the instance, or called creating the fixture. Creating the fixture, creating the instance of the class that you want to test. Then find the method that you want to test of that class. So execute the method. You just add the values, pass the values, and see and different. You can have different combinations. Of the values. And the next phase is the third step is very important, the essence of test-driven development, or JUnit testing, is the asset statement. Here you see what is the input value, what is the expected value, and what is the real value. Okay, so this is the basic steps for JUnit testing. The first is, again, create the instance of the class that you want to test. The next phase is the method that you want to test. Pass or input different values or different combinations, not one combination, different combination, and see what is the and the last step is try to evaluate the results, is basically what is the expected value and the real value. Okay, so let's try to see a kind of a demo. Do you have any questions related to unit testing? Okay, so here, okay, can you see my screen, everyone?
Yes.
Okay, so let's so I'm using as I said, that is, I'm using NetBeans. I was having some issues with my Apache NetBeans, so issues with this, I think, different version. So anyway, so if you can use NetBeans or Eclipse. So so for example, you just want to so test-driven development, you remember, so it's basically what you need to do. You remember, you start with the class you want to test. Sorry. Yeah. So you want to test the tester class to find you start with the simple class. You create the class with it may not have any particular, it may have the skeleton code, that's it, and then you can create the test class, and based on that you can what you can do, you can input different values, different combination, and try to see evaluate the results. So let's start with this one. So let's, for example, which will do a very simple problem, but it'll be helpful to helpful for you to understand the concept of unit testing. So first go there, we have the package TD demo, for example, test driven development. So we have a new file. Let's create a new file, TDD demo Java class. Okay, the next, so let's TDD demo. Then we have fall 2020. Okay, so it's in the source package TDD demo. Okay, now create this one, create the class. So you see, this is a very simple class, the public class TDD demo fall. It doesn't have anything. So so let's just write a skeleton code here. Here, so just give me a second. Okay, TDD demo is here. For example, you just want to add to string. Okay, so here, so basically, so very simple. Public int, maybe we are trying to add to string. Okay, S1, S2. Okay, so a little bit of it's kind of skeleton code. So it doesn't have any main. That's fine. Exactly. So it needs to return something. Just return 0. Okay. So now this is the skeleton code. We don't have, so we have the class, for example, test driven development demo, TD demo fall 2020, whatever, and we have the method, the add. We have to add the to string. Okay, try to make the thing a little bit interesting here. So that's why we have we're trying to add to string here. So it doesn't have any body. So that's exactly fine. That is the exactly the the philosophy of the test driven development. We don't need to you start with the simple skeleton code and you just create the test class for this one. So you're expecting something, we have to return something, so it's a return 0. So there's a simple class. Now let's go to tools and create the test class. So you have automatically create the test class tdd demo dot blah 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 tdd default 2020 test. So now you just create the test class. Okay, so here you can see this is the package here, and so we are importing the JUnit after. So you can see different we have different methods, before, after, before, after. So these methods you can use for for extensive testing. So we are mainly focusing on this part. So you can see the Java test annotation. So you see this part. Okay, so you see our IDE or NetBeans is intelligent enough to create a body to be tested. It's kind of a template. It's already created, so it knows that you're going to test the method add. So it's like test add. So and then you're going to is also intelligent enough to know that we're going to add to string. Okay, and then then as we discussed, we create the instances, creating the fixture. You remember, we're creating the fixture here. So creating the fixed instance, And what is the expected result? So you're expecting some integer here. So again, it's it can so your test class is is expecting some the method is actually expecting some integer value here, and this is you're trying to you're calling the method the add so I'm passing the value s1 and s2, and this is the asset equals. So this is the you're going to evaluate the results. What is the expected value, and what is the results? And there's a fail statement here. You can see it's going to it will force you to fail. Whatever it is, it is going to force you to fail. So let's see what happens. So test class, so it's fine. So here, for example, we are trying to add 2 plus 2 then 4. Okay. Okay, so now okay, so let's see, run the file. Okay, you see it's failed. So let's see why it's failed. So yeah, I was expecting 4, but it was 4 because we see it was returning 0, right? So okay, so here if you put it 0, okay, now you just try to test it again. Okay, one test failed because of this, because let me check what is there. Okay, the test case is a prototype. You see, is going to force to fail. Okay, so that's fine. The first statement. So that is absolutely okay because there's a default statement. So now you see we started with a very simple class like tdd demo fall, and it has a method like add. We just know this, we have a toString to add. What's happening inside we don't know. So therefore I start with a very simple code, production code, and then we created the test code. And the test code you see, and when you use any intelligent IDE, for example Eclipse, NetBeans, and we have a lot of other IDEs are also available. So it will create automatically the method that you want to test. So for example here the test add, and then the is where we are going to add two string values, like expecting to string, and then here the expecting some integer value, and here is creating the fixture. As you said, there's a three-step process: creating the instance of the class to be tested, then the method. You basically select the method you want to test, so you're passing the value. So is the add is the method is passing the values, and the last step you remember is the you evaluate the results. It is in your slides. And again, all these codes are already in the review final review document. Okay. Okay, so let's go back. So that is absolutely fine. We see that test case is test case failed, didn't pass. That's fine because of this statement. So go back to the production code, because now we need to change. We need to add a little bit some more information here. So let's see. Um, so integer. So let's add two integer, for example. So what we can do. Integer change from string to integer, right? I think something wrong here. Parse, okay, that is fine. Strings, okay, and then let me copy and paste it to string here. Okay. Okay, and then return. Okay, save it. So now we have some code here. We try to add to string. So just you know change from integer to string to integer, convert it. Okay. So now go back to the test class here. You can see again Java annotation test. So we have now we need to try to test this code with different input and output combinations. So 2 2, and we're expecting 4 now. Okay, so starting, that's fine. So let us take this out, because otherwise it's whatever your results is going to fail. So now since we have some code, we can take it out. Okay, so now let's see how it works. So run it. Yeah, the test case passed. Okay, so we have only one test case, and it passed. So now let's see the other test case. So because we need to consider different values, right? And so maybe test 1. Maybe you can try to see 2 plus 3. We're expecting 5. Okay, now try to see. Oh, okay. So one test passed, one test failed. What happened? So what is, you can quickly check what's happened. Fail expected 5, but was 6. Okay. Okay, let's see. Here things look fine. Test case. We'll check. Things look fine here. Yeah. So let's go back to our main code. Okay. Yeah, you see, that is the thing here. We had copied and pasted the thing and made some mistake. It should be S1, so it was S2, S1 basically. Okay, so now S2. So okay, now let's go and run it, and both test cases passed. So the similar kind of thing here. Come try another combinations and see what happens. Okay, so it's 2. Save it. Shift F6, and all 3 tests passed. Okay, so 100%. So this good. Everything looks fine. This is basically as a very basic um, basics of test-driven development. So okay, one thing we can also check. Another thing. Okay, so for example, we have this one. Make another test case. Another test here. Test 3. Okay, so now we discussed like unexpected input, right? We discussed this one. So for example, we're expecting to, so how about we just have some something that is not integer. For example, ncat. So what's going to happen here? So just save it, and then instead of integer, we put this string values here, and then try to oh, it's failed, you see. Can anyone tell me what happened here? Any idea?
The result was supposed to be uh, an integer, but you placed in like a word for your string
String,
instead
yeah,
of an actual number.
exactly. So yeah, Marcus, as mentioned. So yes, this is the thing. So now so we have some unexpected input values. So we cannot handle it. So that's why we have this error value. So that's the is the learning process. So now in your test case, you need to make sure what would be your behavior, what kind of behavior you are expecting from the user, and how to react. So if someone put this kind of values, what it will do. So if in the current setup, you see this, it will show you um, the error. So, but quickly, what you can do, you quickly check the error message and try to see what happened there. So you can see this, the input string was ends and cat. So definitely you're expecting some integer value. So the main thing is that you need to, the behavior you need is some kind of, you need to throw the number format exception, you know if it's that's the behavior you are going to expect. So here, to remove this, so for example, there's the behavior that, okay, we can expect this kind of behavior. Okay, so we can still accept this kind of things, like the string instead of the integer value. So here, parenthesis, so here, you can see expected um, um, number format exception. Okay, class. Yeah, so you're expecting number format exception. So here you see, no, the test string. Okay, there's the behavior you want. So now if you run it, let me check, and all four tests passed. So that is basically a very simple way to do the unit testing. It's a very simple examples. So that's why we started with this toString. We're adding this toString, okay, to make the thing a little bit complicated. And so again, so what we did, you remember, you start with this uh, very simple class like TTT demo, and then you had only the method that you want to test, like add, and you went to adding to string s1 and s2. That's it. And initially you didn't have any code, just you're returning 0, just expecting some values. So, and then based on that, you can go to the tools and create the test case. So when you create the test case, it will automatically create the test class. So test class. So you just come here. There's several methods that are available, as you can see. A lot of methods are available, so you don't need to worry too much about that for now. But mainly you need to focus on this area. You can see it's Java annotation.test. So it's automatically create the method that you want to test. So it's intelligent enough to understand what you're going to do. So you create the test add, and then so it's expecting some value like string s1 and s2. And here, as you see, this creating the fixture, we call this instance that we want to create. So you're creating the instance of the class. Then the expected values, it is also intelligent enough to understand or expect the integer value here. Then it is this, you know, mm, create the first step is creating the fixture, and then the method you want to test, like the add method here, you're calling this one and passing these values. And there's the last phase is you're evaluating the results. What is the, using the assert equals assert true. This is the essence of JUnit testing. This is a very important part of unit testing. So you're trying to find the check the values, or evaluate the values, what is the expected results and the real results. Okay, so then we can have different values like 2 to 4, and have another test case, for example 2 plus 3 5, expecting 5. Check what is your expected results. Then you also see whether any unexpected behavior or not. um, So here is basically, so for example, is so you can have maybe uh, different kind of values. It's not the similar values, the different values. And then you also check, is whether it's expecting the integer values, but if you put like input string, what's going to happen and how to handle it. So here, if you want to handle this value, you can put some kind of exception that you can still accept this kind of things. Okay, so to avoid any kind of unexpected errors. Okay. So here, if you want to consider any kind of input string, you can throw a number format exception. Okay, so that's why you just put expected number format exception. So this is basically uh, 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 how you can do the unit testing. As I said, that unit testing is very important for test-driven development. The test-driven development, what is test-driven development? Is again, test-driven development is a very important part of your agile development process. So you have a module, you test it, and you refactor it, test it. So for test-driven development, what you need to know, you need to write a test code, then the production code, and then try to check or verify your production code with the test code and see whether it passes or not, and you have to do again and again. So that's why here what we did, we started with this a very simple test class with the method that you want to test without any particular code inside the test method. It is just a skeleton code, and then we created the test method, and then we are testing. We came back when you have the test class, and then you can come back to your original code, the production code, and add the main the code that you want to test, and then go back to your test class and try to do different combinations, and try to see what is the input value, or what is the input values, what is the expected outputs, and all those kind of things. So this is basically the JUnit testing, or you can call it test-driven development. So you're going to do it as a part of your sprint 2. So I think you'll have it, this kind of thing. So this is basically the agile development, as a part of agile development and a part of test-driven development. Okay, so any questions so far based on test-driven development?
No.
Okay. Okay, so these codes are available, how to do it, because you may have, I can give you a very simple code. So for example, if I give you to add this thing, so this is, if I give you this kind of code, what you need to do, you need to add the this kind of things, you need to write the test case for me. So it's not a problem. You can you don't need to write all these things, that's fine, but you need to write this simple 3-step process. As I said, that is they create the instance, the instance of the class to be tested. Then what is the method that you want to test, pass the values, and the evaluate the result, the 3-step process. So and you can have a different combinations. You can also add this some kind of exception, so that's fine. So okay, so this is basically it's a very simple example of test-driven development or JUnit testing. Okay, so again, the codes codes are already in the review documents, and the review documents in the Blackboard already. Okay, so here let me go back and okay, share screen is here. You see, so this is all this basic steps of test-driven development or JUnit testing. So why JUnit testing is very important, as I said, that as a JUnit testing tool, it's a supports it's a JUnit, actually it's a unit testing tool. It supports test-driven development and support agile programming. So this is pretty good. It's cool for cool features for NetBeans. So you can use now Apache NetBeans, for this kind of testing. And you can also get the flavor of big data as well. Okay, So there's another example here. If, for example, if you give this kind of code, like you can concatenate string 1 and 2 and return 1 and 2, and what is the unit test case? So you probably need to write this as a simple test code. You see, you create the instance, it's a test class you have, then they create the instance, pass the values, okay, create, and then the method they want to test, and this they evaluate the result. This 3-step process. You see, there's a 3-step process. Create the fixture or instance, execute the method to be tested, and this evaluate the results. Okay, so this is very simple. So few examples which we have seen. One there's a one. Here's the process. There's the example related to the method that we're discussing, like the point of sale method, and this is an example, and another example is given. Detailed example is given with all the steps in the review the documents. Okay. Okay, so this is basically what we have today for this unit testing. So let's stop it now. So okay, so stop recording here.